Decimal multiplication is very similar to whole number multiplication. So the first thing to do is to understand that, unlike in addition, you don't need to line up the decimal points. You just need to have the numbers lined up, like right justified, so that you can multiply each digit by the next. We're going to just multiply as usual. You can use a standard algorithm or you can use an area model. So if you're using an area model, instead of thinking of 1 and 23 hundredths times 2 and 34 hundredths, you can just think of 123 times 234 and just use an area model, or you can use the standard algorithm as shown. The number of digits behind the decimal point in the answer should match the total number of digits behind the decimal point in both factors. So we have 23 hundredths behind the decimal point, so that's 2 digits, and then we have 34 hundredths behind the decimal point, that's 2 more digits for a total of 4 digits behind the decimal point in our answer. So this is our answer here. We have 4 digits behind the decimal point, and that helps you to place the decimal point in the correct place. So let's think about why that works, to help understand, help remember that rule. So since decimals represent fractional amounts, then you're just going to use the same rules for fractions. So here I have 31 hundredths times 10, which is the same as this, 31 hundredths. Those represent the same exact number. So 31 hundredths times 10 equals 310 hundredths. So if I reduce that fraction, I have 31 tenths, which is the same as 3 and 1/10, because that represents a fraction greater than 1. Okay, so here it's the same thing. If you were going to use a standard algorithm to multiply 31 hundredths times 10, just like I did on the last slide, this is what you would do, and then you're going to place that decimal point with 2 digits behind the decimal point, because we have 2 digits behind the decimal point in 31 hundredths. So there's just the 2 total, so that's where we place the decimal point. So that's why that's an effective strategy to use. It can help you place the decimal point correctly. Now for decimal division, we need to think about this in a slightly different way. So I'm starting with just whole number division. So I am doing 1,621 divided by 12. So my first step would be, okay, how many groups of 12 can I make from 16? And that's one group without going over. So that's how I start a whole number division problem. And that's going to help us understand decimal division. Okay, so here let's look at this second pattern. So both of these simpler problems help us to understand why we use the particular strategy that we do for decimal division. So here I have 50 divided by 5 equals 10. If I multiply both of those numbers by 10, so I do 50 times 10 equals 500, 5 times 10 equals 50, I still maintain that same answer of 10. Okay, same thing if I multiply it by 10 an additional time. The quotient or answer to that division problem is staying the same. This pattern is going to help you understand what I'm about to do next. So here, now I do have 2 decimal numbers that I'm dividing. Okay, so in the first example, I had 1,621 divided by 12. This time I have 16 and 21 hundredths divided by 1 and 2/10. When you're dividing, you would be then doing how many groups of 1 and 2/10 are there in 16? And it's difficult to conceptualize it, especially as you go deeper and deeper into the division. So therefore, what we're going to do at the beginning is multiply both numbers by 10 until we have a whole number divisor. So the divisor here is this number, 1 and 2/10. This is the divisor. So I'm trying to make this be a whole number. Okay, so sometimes people think about this as moving the decimal point, but as you know, when you're multiplying by 10, you are moving the decimal point to the right. So here I'm multiplying both numbers by 10, so then I have 12, and then I have 162 and 1/10. So then you can just go ahead and divide as usual. The decimal point in the answer will go directly above the decimal point in the dividend, which is 162 and 1/10. And then there it is. Okay, and at the end of the division problem, we're not writing the remainder like, 13 and 5/10 are 1, as we sometimes do. We're going to include it as part of the problem. So here, I'm going to add an additional 0 right here at the end, bring that down, and then that will become the next partial dividend that I'm using when I'm dividing. So at the end of the problem, I had 1. Now I added an additional 0, brought it down, and then how many groups of 12 can I make out of 10? I can make 0 groups, so I have a 0, and there is how we continue with the problem. So right here, remember when you add a 0 to the end of a decimal, it does not change the number because of the way that place value works with decimals. So here I had 1/10, and that's the same as 10 hundredths. When I add the 0, now it's in the hundredths place, but those are equivalent fractions. So here you might say, well, when do I stop? I still have a remainder. So the typical protocol, if it does not explicitly say to stop at a particular place value, just stop at the hundredths place. Okay, so we just go to 2 decimal points, even if there's still a remainder, because it could go on forever. And there needs to be a stopping point when we're trying to figure out the answer to a problem. Okay, so this is an approximation, technically speaking, but we're just going to use the standard, just going to 2 decimal points when there is still a remainder. Sometimes there won't be a remainder anymore. It will divide evenly, but if not, just stop at 2 decimal points unless you are told to do otherwise.